would be it would be it would be a normal vehicle, as the conventional normal vehicle we use. It need to be registered in the RTO. It will have a number plate, it would have an RC, it need to have an insurance. Every rules that applies on a normal bike will be applied on a high speed bike. Only thing is it would be differentiated with a number plate, green number plate. So it would be differentiated with a green number plate. You would have a green number plate on that. So budget. So if you are someone who is like happy with a low speed vehicle, so you can go with a low speed vehicle that would be considerably at a lower price. And if you need to have, if you want speed, you want like higher mileage, then you will go for a high speed vehicle. So in high speed, I said there are a lot of variants. You can go for Ather, then you have an option of Ola, Okinawa, Revolt, Hero, TVS, Chetak. All these are in the high speed segment. So you have to look at your budget, like what suits you, what's your cutoff, where you want to, the prices that is there in your mind for which you want to buy. So in that also you see, if you find that you are buying a vehicle only for office commutation, or going to your college and coming back, and you know that you will be like on full working day, you would be traveling at the most 30 to 40 kilometers. So why buy a vehicle which is very costly, and which is claiming to give you a range of 120 kilometers? Because in any case you will be only traveling 30 to 40 kilometers, and every night you can get it charged. So if you can go with a lower battery capacity, and there you can save price. So these would be the deciding points, like what kind of EV you want to go for. So if your traveling is less, you can negotiate with the battery size, and there you can get you can make some savings, and you can get a bike at a cheaper cost. Quality of service, repair and maintenance. So what typically is happening in this segment, if you talk about normal two-wheeler, when you come out of your house, within 1 kilometer you would find like 20, 30 numbers of people who are either like repairing bikes, or who are making the puncture of the bikes, and like different set of people would be there. But you will be able to find a mechanic, say, within half a kilometer, wherever you are. If you are in a city, you will find every half kilometer you would find a mechanic. If in worst cases, you can move to any petrol pump, there you would find someone, a mechanic, which could repair your bike. But if you talk about EV, still the infrastructure has not developed. There are very few people who would be like repairing or repairing these EV bikes. Most of, if you go to a normal mechanic, he might deny you, saying that he is not aware of the system of this bike, so he will not be able to repair. So so when you are purchasing a bike, you need to have you need to see that the bike that you are purchasing, it has a proper showroom in your city, so that if in worst case, if some fault arises, if some typical fault arises, you can go there, and you can ask them to fix it. Otherwise, what happens is, if you have purchased some bikes and you don't have any service network in your city, then you will either you will have to wait a very long time till the person from other cities comes to see your bike and fix it. So this is a very like important point to be noted when you are going for an EV. Availability of battery swapping services. So typically, what is a battery swapping service? Battery swapping service, it's like kind of a give and exchange kind of a place where you give your drained battery, and you get a fully charged battery, you get it. So how does that help? That help in that help us, like if we are moving somewhere, and if our battery drains out, so instead of waiting for getting charged for say 1 hour or 2 hour of wait, we can easily move to a swapping station. We can get a fully charged battery, we can give the drain battery, we will pay a small price for getting it charged, and like we can move on. So it would be kind of like very much similar to what we do at a petrol filling station. We go there, we fill our tank, and then we move. So it hardly takes 1 minute or two till from filling our tank, making payment, and moving out of the petrol pump. So swapping station is like that only. That is a concept where you deposit your drain battery and you get a fully charged battery by paying a price. So is charging an EV cheaper than buying gas? So definitely EV charging is cheaper than buying gas. If say if you are, let's take an example that if your vehicle has a, say typical a battery of 3 kilowatt battery is there, and it is giving you a range of 90 kilometers, it gives you a range. So 3 kilowatt battery, say from fully drained to fully charged, it will take three units of electricity. So if you talk about any state in India, the highest maybe it wouldn't be more than 10 rupees per unit. It won't be anywhere. It won't be more than 10 rupees per unit. So if you consider that cost, it would cost you only 30 rupees to get it fully charged. So with 30 rupees, you can move from you can travel for 90 kilometers. So that is like kind of 0.3 rupees or 30 paisa per kilometer is what it costs you. But if you talk about a typical conventional vehicle, it's if I talk about a bike that gives you a range of say 50 kilometers per liter, that gives you a range. So if petrol we talk about, it's 100 rupees anywhere, whatever whichever state you talk about, it's close to 100 everywhere. So 100 divided by 50, 2 rupees per kilometer. So in that way, the operating cost is much lesser for EVs when compared to the conventional vehicles. Are electric vehicles affordable? So electrical vehicles are affordable. Yes, they are affordable. Affordable, like if you talk about few years back, definitely the initial cost was much higher. But now, since with the increase and with the increase in the scale and with the people being purchasing, the numbers get increasing, the costs are also coming down. At the same time, central government and the state government, respective state governments, they are giving incentives. So a central government gives you some incentive when you purchase an electrical vehicle. At the same time, the state government also gives you some incentives when you purchase an electrical. So this way, what has happened now is that the costs are very much comparable to a conventional vehicle. So if you talk about a typical EV, so it would cost you around, say, with after reducing subsidy and everything, it would be costing you around 80 to 85,000 rupees per for a vehicle. It would be cost. Same is the cost if you talk about normal. If you talk about an Activa or other scooty, if you talk about, the cost is very much comparable to that. So the costs have very much comparable to both the vehicles. The costs are very much comparable, and the operating costs are much lower for EVs. The only thing is that the EVs are for the battery life of an EV is for 5 years, whereas if you talk about a normal conventional vehicles, you can the age the life of a normal vehicle is 15 years. If you talk about the RTO norms, it is 15 years. So you would say that then conventional vehicle is better. No, conventional vehicle is not better, because with every aging year, it is also like increasing. There is a exponential increase in the service and the maintenance cost of the vehicles also. So if you add up everything, if you add up the operating cost, you would see that even if you consider the whole life of an EV and a normal vehicle, you will find that EVs are would be much cost effective and would be much cheaper than a normal conventional vehicle. So if say after 5 years, if you replace your battery, then you again get a life of 5 years. And this way you can if you compare the life of a normal vehicle and an EV, so you would need 3 batteries to compare to make both the life cycles equal. And when you will see that the cost that it will incur per kilometer, the cost it will incur during its life cycle, and the EV during its life cycle, they would be like EV would be a better option. It would be, you would make a saving when you through an EV. How and where would I charge an EV? So if you talk about a 2-wheeler or a 3-wheeler, you can easily charge it at home. It's not an issue. You can plug in the charger in your normal plug point, 5 ampere, or at the max the 16 ampere plug you can plug in, and you can charge your electrical vehicle. But if you talk about a 4-wheeler, that 4-wheeler, actually the chargers require much, they charge at a kilowatt level, which is much higher than what is our connected demand of a house. So you can't charge it through a normal plug point. You need to have a backup proper installation you need to have, so that you could safely charge the four-wheeler. So two-wheelers, yes, definitely with your domestic supply and at your home you can charge it. But if you talk about four-wheelers, they can't be charged normally through your domestic supply. So why electrical vehicle? Increasing automobiles leads to increase in pollution. Transportation is a major source of air pollution in many countries around the world due to high number of vehicles on the roads. Vehicles introduce toxic materials into the atmosphere that have several bad effects on human health and ecosystem. Examples of such pollutants include carbon monoxide, hydrogen nitroxide, a particulate matter, ammonia, and sulfur. So now the big question is like why the entire world is going behind, like is running behind want to have an electrical vehicle in their country. So the major concern is the pollution. We are witnessing the like last 3-4 years we are witnessing the effects of pollution, or you could say that the environmental changes that are happening, global warming and all the effects we are witnessing ourselves. We are witnessing in some cities where there were no rainfall at all. If I talk about, say, I come from Rajasthan, which is a desert state. So the amount of rainfall has increased drastically. Whereas if you talk about some other states where there was excessive rainfall, the rainfall has come down. Or you would if you talk about hilly states or hilly places in India, you would find that there are floods every year. We are witnessing floods. There are loss of life and the loss of property is happening. So these are happening because of global warming. And before, we used to only talk that there is global warming, the temperature is increasing, it would have drastic effect on the globe. But now we are witnessing every year during the rainy season, if you look into the news, you would find that there are several cases where floods have occurred and there has been loss of life, loss of property. So these are the drastic effects of global warming. So how can we can't alter global warming, but we can reduce the pace, and we could give like our mother earth some time, so that it could again recuperate, and it again can like heal, and can again give us a better environment and better atmosphere where we can live like without any say with fresh air and everything. So countries are what they are switching towards are renewable energy sources they are switching to, and they are trying to adopt. So if I talk about transportation, you would see that transportation is the major pollution creator in any country you talk about, whether it is public transport, whether for like logistics, or whether for private transport. You are dependent on, in one or the other format, you are dependent on something that is running on gasoline. Today we see that hardly like we ride cycles. We are mostly, in every house we have a two-wheeler which is run on petrol, or we have a four-wheeler which is run on petrol or diesel. So we can transportation and in the logistics, how much air pollution is being caused. So to bring down this cost, just to check, am I audible?
Yeah. You're audible.
Yeah, it's fine, right? No disconnect. Yeah, okay. Sorry. So like this effect of air pollution, to bring the effect of air pollution, every country want to switch to renewable energy and to electrical vehicles, so that they could reduce the drastic effect of pollution. Very like a few days back, you must have heard that Britain has taken like their parliament has passed a bill that by 2035 they won't be manufacturing any IC engine. What does that mean? That by 2035 they want to convert the entire the entire vehicle fleet, whether it is for transportation, public transport, everything they want to convert to EV. So uh, that kind of enforcement is done by every country for the adoption of the EVs. So at the same time, some of you could like query that, say we have adopted EVs, okay, but uh, if for the charging we are utilizing a normal grid power only, okay. So our normal grid, if you talk about India, the normal grid is 80% fossil fuel. That is 80% of the generation is done through coal. It's coal based. Okay. So in one or the other case, like we can't say that yes, we are fully 100%. We are pollution free, or we are not creating pollution in any way. So for to overcome that, what second scheme is being done is we are going for solar and other renewable energy, so that the percentage of coal generation in the grid can be reduced, and the percentage of energy through renewable energy could be increased, so that when you are charging, you could say yes, like my vehicle is 100%, it is renewable, it is not using any kind of fossil fuel, it is not using. So for the electrical vehicles could be a boom if it is accepted on a wider scale. Yes, it can definitely help in bringing down the pollution level. Now not only in two-wheelers, that what government has done is government has asked that yesterday, as we spoke about, by 2030 30% of fleet to be converted to EVs. So still now effort has been being made. So if you see in two-wheelers, sale has drastically increased. Three-wheelers, if you talk about, they have surpassed the conventional three-wheelers. So in case of three-wheelers, what happens is like three-wheelers are mostly meant for intra-city transport only. Within the city, they will travel for 50-60 kilometers. They will travel, and they for say for logistic purposes, from moving from one place to another. So if you they switch to EV, the cost of the vehicle is very much comparable to a normal vehicle, and at the same time they save on the operation cost. So more and more people who were driving three-wheelers, they are shifting to electrical three-wheelers, and at the same time the loading capacity for both the vehicles is also equal. There is hardly any difference between the loading capacity of both the vehicles. Okay. And if you talk about four-wheelers, definitely new players are coming now. If you talk about India, the largest player is Tata only, and these taxi services, they are converting into EVs. You must have heard about you so new taxi services that are coming. So they are also introducing electrical vehicles, electrical cars into their fleet. At the same time, government departments, the transport departments, what they are doing, the public transport system which are run on the buses, they are trying to convert maximum buses, they are trying to convert to electrical, so that the public transport becomes fully comes on EV. So this taxi aggregator Blue Smart, you must have heard about. So I don't know whether it is operational in South India or not, but in like NCR, it is taxi aggregator very much like Ola and Uber, and they have only EV fleet, and they have tied up with Tata, where they would be giving them 5,000 new cars they would be giving them. And so this way, like initiatives are being done to convert to EVs. And if we definitely, if majority of the fleet is converted into EVs, there would be a very positive impact on the pollution. So this picture, many of you, if you, every one of you can see this picture. This is a typical picture taken during in the winters in Delhi. Okay, so you can see the haziness. So this is all smoke around, and you can literally feel it if you visit, any one of you visit Delhi during the winters. You would see that the whole day, like you won't see any sunlight. You would feel haziness, and this is all smoke. And smoke or pollution, you could call, which causes a lot of breathing problems, and air quality is very low during that time. So for all these purposes, to make the air healthy and to make fresh, we should go for EV. So price volatility in the resources of fossil fuels between 2020 and 2030, global coal, oil, and gas production world have to decline annually by 11%, 4%, and 3% respectively to be consistent with 1.5 degrees centigrade pathway. So this is the 1.5 degree centigrade pathway is a Paris Convention, in which it has been accepted by every country that they will make effort that the average temperature of the earth doesn't rises by 1.5 degrees centigrade during this 20 to 30 2020 and 2030. During this decade, the average temperature of earth doesn't rises by 1.5 degrees centigrade. And for this, you have to you can't like bring down the industrialization, because if you bring down industrialization, there would be a lot of jobs would be lost. So to make air healthy, you can cut down the emissions caused by the transportation and by the vehicles in the logistics department. So you if you convert them, maximize and convert them into EVs, definitely the emissions there would be coming down, and you could maintain this 1.5 degrees centigrade average temperature rise. It could be maintained. And at the same time, if you talk about a country like India or Japan, who are mostly dependent upon other countries for their fossil fuel requirement, we import ours in around 90% of our energy requirement is imported from other countries. At the same time, not only like petroleum products, but also coal. India has abundance of coal, but the quality of coal is not that good. So you would see that many of the power plants of the power generating companies, they are importing coal from either Indonesia or Australia. So in this way, we are losing a big fat amount of our exchequer, foreign exchange. We are losing in paying for these imports. So if we can have electrical vehicles deployed, which could be charged through renewable energy sources, say solar or hydro, which is again produced in our country only. So this way we complete the whole cycle. We could say that yes, we are self-sustainable country, and we could complete entire all the goal sets of a sustainability. So we could have our generation in house, and at the same time the transportation could be completely is complete if it's converted to EV, considerable amount is converted to EV. We don't have to import a big chunk of fossil fuels in the country, and at the same time like we reduce the emissions also. So increasing greenhouse emissions in the atmosphere, climate forcing refer to a change in the Earth's energy balance, leading to their warming or cooling effect over time. An increase in the atmospheric concentration of greenhouse gases produce a positive climate forcing or warming effect. From 1990 to 2019, the total warming effect from greenhouse gases added by humans to the Earth's atmosphere increased by 45%. The warming effect associated with carbon dioxide alone increased by 36%. So these parameters, the global warming, or the or you could say the purity of the air that has come down, and we are facing such a low quality. We are having to like breathe such low quality of air. At some points, it was compared that in Delhi during winters, it is better when you are inhaling the normal air, it is like kind of like you are consuming say 10 to 15 cigarettes you are consuming. So that low is the quality of the air during winters in Delhi and around area. So that where has that come from? That has normally come from like pollution caused by from industrialization and caused by the vehicles which run in the vehicles running in the transportation and the logistics. So EV can be a solution. We can drastically bring down the emissions if it completely, if we, or 40 to 50% of our transportation we are able to convert to EV, we can make a drastic change in the quality of the air. And at the same time, if you see that what global warming and other effects that they are causing is not only in the quality of the air, but they are also affecting the normal our flora and fauna and also the hilly areas, they are getting affected. You are those areas are witnessing more like erratic floods they are witnessing. You would hear like cases of cloud burst and all those news you will hear. So these are all effect of global warming. So global warming, see, it can't be like it can't be like moved away like in a single day, that we can repair our ozone layer and we can go with emissions. We can't. It has to be done step by step. It has to be done. So the major could be, yes, adopting like greener transportation, and secondly at the same time adopting renewable energy sources for another power consumption. So these are two major sources through which we can bring drastic change. We can definitely bring down the emissions. We can improve the global warming. So mostly every country is making their efforts in adopting renewable energy sources and in adopting clean environment friendly transportation. Global warming CRB regulation. The California Air Resources Board approved amendments to its current rule for transport refrigeration units operating in the state. The 2022 amendments will require a variety of actions designed to reduce the pollution these units produce and accelerate their transition to zero emission technologies. So what is happening is, I said, yes, definitely emissions are being caused by transportation, then during energy generation and industrialization, but at the same time one major contributor to our uh, uh, which are damaging our environment is the use of air conditioning and refrigeration. So they emit gases which affects our environment drastically. They affects our environment. So now this regulation that we are talking about now, they are enhancing or enforcing that we come up with technologies so that we have zero emission technologies. We could like through refrigeration and air conditioning we can bring that they don't damage our environment by emitting gases, harm gases. 14 of 20's most populated cities of world in India, 36% NOx emissions in atmosphere due to vehicles, 20% particulate matter PM 2.5 emission in Delhi due to vehicles. So as we were talking about adopting green transportation, we were talking about. So why it is it is now an necessity like to adopt green transportation and renewable energy. These data will make it much clear. So 14 of 20 most polluted cities of world in India. So if you talk about recently also, like 2 days or 3 days back, the most populated cities, Delhi was considered the most populated city in the world. So, and if you see the list of top 100 cities, you would see that, or in fact 20 most polluted cities list, if you see, 14 are from our country. Okay. And the pollution, 36% NOx emissions in atmosphere due to vehicles. So if you talk about nitrous oxide and its compounds, if you talk about which are the major pollutants of the atmosphere, you would see that major pollution is coming from vehicles, or from the transportation it is coming from. So use of vehicles, if excuse me, so use of vehicles is contributing the maximum to pollute the atmosphere. 20% particulate matter PM 2.5 emission in Delhi due to vehicles. So you must have heard about PM 2.5. So it is again again a factor to to check the quality of the air. And if it is above a certain level, then we call it that the air is hazardous or not fit to breathe. But if you talk about few places in our country, we will find that for 75% of the time in a year, they are below, they are above the hazardous level. So they are never the hazardous level is either into the red category, or it is into the moderate level. It is never for a very limited time you would find that the air quality is better or good. So and mostly the our capital Delhi and the surrounding areas are mostly affected by this, but the contribution of these suspended particles or 2.5 ppm particles that we call them, that comes from contribution of 20% comes from vehicles only. So here we are trying to show you a graph like first EV is 4 times more energy efficient than IC. IC efficiency 22 to 23%, motor energy efficiency 90%, 50 times less moving parts than IC. So say if we compare a normal electrical vehicle with a conventional vehicle, you would see that the efficiency level. So if you talk about the efficiency level of a normal conventional vehicles, it is close to 20 to 25% the efficiency. So what does that mean? That means that the fuel that you have filled in your car or your scooter, that will give you only 20% efficient, and rest 80% is either converted into like flue gases, that is converted into, or it is lost in other heat or in other formats, it is lost, and these gases are released into the atmosphere and to pollute the atmosphere. But if you talk about EVs, the efficiency since it has very less moving parts, if you talk about an EV only, the moving part is in the format of a motor or the wheel. If you talk about a hub motor, then it is the wheel, or if it is a mid-drive motor, So the motor is the only moving part, and efficiency of motor, if you everyone of us know that it is above 85%. So this way, the energy that is the battery is again a static part where the losses is very limited, say 2 or 3% losses are there. Then intermediate losses, maybe some losses in your controller or in your wiring harness, that is again 2 to 3%. So overall efficiency, if you talk about, it's about 80 to 90% efficiency we get in an EV. So whatever the losses could be, like when we are charging the battery, there could be some losses, like it could be say 80% of the energy that we are that we are supplying to charge a battery. So 20% there we can see some losses there, but when it is operating, then it gives you an efficiency of around 90%, which is much higher in comparison to an IC engine. Again, a major advantage, if we talk about for EVs, we have seen that in EVs there are very less moving parts. If you dismantle a EV, like when you definitely when you will be going for hands-on practical training in Osmania University, there you will have an opportunity like to dismantle a vehicle and again assemble it. Then you would see that how less parts are there. There are very, like, you can count all the parts, you can count on your like fingertips, you can count. There will be 10-15 parts and you can disassemble the entire vehicle. But then again, if you talk about a normal vehicle, the engine itself is composed, or it is made up of hundreds of parts, hundreds of moving parts it is made up of. So that gives an higher efficiency to the EV. So it has less moving parts and higher efficiency. That is again a big advantage over the IC engine. 40x times increase in import bill of petroleum products of India from 1981 to 2018. So like what has happened is 1981 to 2018, if 2 decades, if we talk about, what has happened is we as a country, or 4 decades if I talk about. So what has happened is we have witnessed we have seen a growth in our economy, and growth is directly proportional to industrialization and bringing wealth to the people. So industrialization means industrialization, if you talk about, so it is mostly in industry also require a major chunk of fuel it requires. Maybe it would be some petroleum products, or say for meeting its power requirements, there would be like power plant which would be fueled by either by petroleum products or by coal. So in any way, with the increase in, say, disposable income, more and more people have started buying vehicles, and with industrialization, the transportation and the logistics have increased. the expansion of the vehicles has happened, like more airports have come up. We have now like flights for every city, we have flights. So what has these contributed to? All these are run on fossil fuels only. So just to meet the demand, we have to, because as a country, if we talk about India as a country, we don't have any much resources for the petroleum products. We have to import everything. This is contributed, or this has made, I would say, a loss to our economy by 40x times it has increased. The fuel bill, if you talk about the petroleum bill, if you talk about, so this much revenue or the foreign exchequer has gone to different countries. So whatever we have earned through our hard money, that this we have to pay to other countries. So if we say, if we can develop some transportation system which is, as we said, self-sustainable, and which could be powered through renewable energy generated in our own country, and if we can manufacture the entire vehicle in our own country, so what we would be doing is we would be saving a major portion of this exchequer. So we can reduce our bill for paying to other countries for petroleum products, and maybe we can utilize that amount for some other development activities. So a normal question, like how EVs are different from a normal vehicle. So EVs have a battery instead of a gasoline tank and a motor instead of an IC. So normal vehicle, the source of energy is, or the source of energy to run or the engine is through petrol, and the petrol is stored in your petrol tank. So if you talk about EVs, it is the battery which is the source of, and you can compare it with the petrol tank of your vehicle. EV consists of electrical machines, power electronic converters, electric energy sources, and storage devices and electronic controller. So if you talk about a normal vehicle, there are some electronics are there, but if you talk about EVs, mostly the controlling and everything is done through electronic components. So EV would have normally, as I said, it would have a battery as a source, and motor would be there, which would be the drive would be done with the help of the motor, and the entire controlling of the vehicle will be done through some electronic components. Say controller would be there. So controller is considered as the brain of an EV. So what it does is it receives the inputs. It receives the inputs, and it maintains like what output has to be given to the motor, and what should be the what should be the speed of the motor, how much torque the motor should have. Everything is been decided by the controller. So it is normally the brain of an EV, and it is a fully an electronic device with having a microcontroller into it, which is programmed, conditionally programmed, that in what condition it has to take what steps. Temperature sensors are there, and like at where should it limit the speed. If the load is high, where should it cut off. It would also sense the motor temperature, and it is like a it's a combination. It takes input from all the devices, and then it gives output to the motor, like how it has to perform, or what would be the reaction of the motor from after collecting all the inputs. EVs produce no tailpipe emissions. So tailpipe emissions that we normally associate, this word is associated with normally the normal electrical vehicles. No, sorry, the normal ICE vehicles, the internal combustion engine vehicles. So every vehicle that you speak about, they will have a silencer that we call it. So through that, the emissions would be discharged to the environment. So an EV doesn't have a silencer because there are hardly any emissions. There is no emissions, so that doesn't require. So it has no tailpipe emissions. It has no tailpipe and no emissions. So regenerative braking is possible in EVs. What is regenerative braking? Regenerative braking is possible in EVs in a sense, like when EV is like when electrical vehicles are moving and we apply brake. At that time, the back EMF compensates, and it supplies some fraction of an electricity it's produced, and it again supplies to the battery, which increases the SOC of the battery. So you the mileage of the battery can increase, say 1 or 2%. It doesn't make a very considerable amount of effect in two-wheelers, but definitely it can make considerable effect in four-wheelers. EV is a broad concept that majorly includes BEV, HEV, FECV, etc. So EVs are virtually silent, instant acceleration and a low center of gravity. So EV is virtually silent. There is no noise in EVs. So if you talk about EVs, there is no combustion engine, so there is no noise in EV. Instant acceleration, the torque is very high. You apply, you give the throttle or the accelerator that we call, just you would like rotate the accelerator and you would feel that it's instant at an instant. What the signal that you have given, it would translate into a torque and you will feel it. So EVs, if you say that they would go to their top speed within seconds, they could reach to their top speed. And a low center of gravity. Low center of gravity, it's since the battery, that if you talk about, normally compare with normal bike, and if you compare it with an electrical bike, you would see that the battery is placed much lower. So much lower at a height which is much lower from the ground. So it maintains a center of gravity which is much lower. So if the low the central gravity, it is directly proportional to the vehicle balancing, and the vehicle would be much stable if the if there is low gravity. The gravity is low, means they are terrific to drive and easy to operate. So it would be much stable vehicle, you could say. So here you have been given some block diagrams: propulsion system, wheels, energy source, and auxiliary power. So energy source is the battery. So it gives with the help of through a controller. In between there would be a controller. So energy source is connected to the controller, and controller supplies the power after taking accordingly after taking the input. They would give you an output to the motor. The propulsion system is the motor. So, and wheels, the propulsion system here, it can be of two types. If it is a hub motor, the wheel would be, or the hub motor would be acting as the wheel rim. So there the wheel is directly mounted on the motor. And if it is a mid drive, then it would be the wheel would be driven with the help of a battery or a nylon belt or a chain. Right. And auxiliary power. So auxiliary power, if you talk about auxiliary power, the lighting and the other system of an electrical vehicles, they will also take input directly from the battery. There will be a DC-DC converter installed in between an energy source and the auxiliary power. So what DC-DC converter typically does is it can whatever is the voltage of the battery, it will step down the voltage to 12 volt, because normally the lighting and everything is designed on 12 volt only. So it would reduce it to 12 volt, and then we could run the supply. We could run the lighting system or the ignition system, and all those things we could run easily. We can run. Charging the battery may increase. So there is a note like charging the battery may increase pollution at the power. Charging the battery may increase pollution at the power plant, but total emission in EV energy sources like wind. So as we spoke earlier, that we could counter that. Yes, we are claiming that EVs are 100% renewable, but at the same time they are using the power that they are using for charging, they are using from a normal grid. A normal grid which is comprised of 80% of our 80% of coal. So how can we term it as 100% renewable? So this way, what if we compare it with the emissions caused by the coal and the emissions caused by the fuel, so the emissions caused by the coal is much lesser when compared to the petroleum products or the gasoline. And at the same time, if we can like shift to renewable energy sources, say wind, hydro, or solar, for charging these charging the EVs, then we can claim that yes, they say 80 or 85%, we can claim that yes, we are zero carbon neutral, or we could say there are no emissions involved in the this is a 80% green transportation we can claim. So components of like EVs. So there are two pictures you could see it. So one is a typical scooter and another is a bike. So what we could see is a motor is installed in there. Then you have battery there. Then power drive unit is there. Power drive unit can vary. Like it could be, if it is a hub motor, then you don't need any like power drive unit. You don't need, the tire would be mounted on the wheel itself. So this would actually this rim, the rear wheel would be a motor and tire would be mounted on. But if it is a mid-drive motor, if it is a mid-drive, then you would be placing your motor somewhere over here. Okay, so if it is placed here, then it would be driven with the help of a belt. So there would be a nylon belt or a chain would be there attached to the rear wheel, through which it would be running. And DC converter, DC loads that so DC converter is typically used for stepping down the battery voltage to 12 volt, so that all the auxiliaries of a vehicle which are normally rated at 12 volt, they can easily run. Low voltage battery normally, if DC converter is used, this low voltage battery is not used in two-wheelers or three-wheelers, because you can directly take an input from the primary battery with the help of the DC converter. You can step it down and then you can use it for the auxiliary connections. Vehicle sensors. So what are the vehicle sensors? Vehicle sensors are normally installed in the controller itself. So at what time how vehicle would be performing, so those would be taking the decisions, like there could be some sensors, like if there is a drift or if the vehicle inclines or if it is falling down. So there could be some actuators or sensor who would they would switch off the supply. So that kind of sensors would be there in the vehicles. And a meter or SOC that we call, or the cluster we could call. So what is this? This gives you the actual condition of the vehicles, or it is a visualization of what's happening in the vehicle. So it could be a normal cluster where it will be giving you the state of charge of the battery, and it would be giving you the total speed at which it is traveling, how much kilometers it has. And this cluster, if you talk on some vehicles, it could be as smart as a tab or a mobile phone, you could say. You can navigate through that, or you can remotely control your bike. You can auto lock it and you can auto unlock it. And you could even like if you want to you can stop your vehicle, and if you want to surf internet, you can do that. And if you want to listen to the music, you can do that. Those all things can be done. So the cluster can be made as smart as it can be. Here in the bike, if you see, the same things are there. So tires are there. Transmission system, as I spoke about, since it doesn't have a hub motor, it has a mid-drive motor. So with the help of the belt, the rear wheel is driven, and electrical motor is placed in the mid. So we call it a mid-drive vehicle. We call it. And then there are batteries and three-phase inverter. Inverter. If you talk about an inverter, it is not generally used in two-wheelers and three-wheelers. Inverters are normally used in four-wheelers, because those are run with the through induction motors, and induction motor runs on AC power. So DC from battery is converted into AC with the help of the inverter, and then that motors are run. So three-phase inverter you would mostly find in the four-wheelers. So the main components of electric cars in almost all types of electric car as follows: traction battery pack. It acts as an electrical energy storage system in the form of direct current, electricity, DC. When it receives signal from the controller, the battery will flow DC to the inverter, which will be used to drive the motor. The type of battery is used is a rechargeable battery that is arranged in such a way to form what is called a traction battery pack. So the battery that you are seeing, it is a lead acid battery. Now, typically, if you talk about modern vehicles, we see that mostly they are powered by lithium-ion batteries. So it's an like array of batteries, array of cells are arranged to reach to a considerable voltage and AH, with the help of which the vehicle could run. So if you talk about a four-wheeler, they mostly use induction motor, which three-phase induction motor. And the induction motor, as we know, that runs on AC current. So the source is DC. with the help of the battery, the battery supply is powered, which is converted with the help of the inverter into AC, and then through a VCU, voltage control unit, or we could say it's VFDs, that is supplied to the motor, and the motor controlling is done with the voltage control unit. And at the same time, there are DC-DC converters also, which step down the battery voltage to 12 volt and supplies power to the auxiliary of the vehicles. Controller, as we spoke about the controller, the brain of EV, it acts as a regulator of electric energy from batteries and inverters that will be distributed to electric motors. The controller itself gets the main input from the car pedal, which is set by the driver. The pedal setting will determine the frequency or voltage variation that will enter the motor, and at the same time determine the car speed. So if you talk about a car, a two-wheeler or a three-wheeler, the manual input is through accelerator, whether it is a like foot operated or it is a hand operated. So when we when we are driving a scooter, we find that the road is empty, now I need to increase the speed, so I will twist my accelerator, the angular I will increase the angular angle of the twisting. So say by 1 degree I increase it, so that signal, that manual signal, would go to the controller, which has like analog to digital signal converter. So that will convert that analog signal to digital, and then there is another pulse width modulation circuit inside the controller. What that would do is that would generate a pulse, and that pulse will again trigger. There are set of MOSFETs that are there in the controller. So that pulse will trigger the MOSFET, and those MOSFETs will supply a particular voltage to the motor to run at that particular speed. So say if I am running at 30 kilometers per hour, and I say that I want to increase the speed to 50 kilometers. So I twist the accelerator. That accelerator signal, the analog signal, is converted into digital signal that is converted in the controller. That digital signal is supplied to the pulse width modulation circuit. That from there pulse width is generated, which triggers triggers the MOSFETs those are there in the controller, and then the MOSFET will accordingly supply voltage to the motor. So motor again has Hall sensors are again there installed in the motor, which will communicate and which will communicate with the motor and the controller. So this way controller is communicating in receiving the manual signal, and again then supplying signals to the different parts of the vehicle. So not only to the motor, the lighting, the ignition, the anti-theft locking, everything is controlled through the controller. So power inverter, it converts DC from the battery into AC, and then this alternating current is used by an electric motor. The inverter can change the speed at which the motor rotates by adjusting the frequency of the alternating current. It can also increase and decrease the power of the motor by adjusting the amplitude of the signal. So inverter, as we spoke about, they are generally not used in the two-wheelers and the three-wheelers, because in case of two-wheelers and three-wheelers, we are generally using the DC motors only. So they take input from the battery directly, and then they perform. But if you talk about four-wheelers, so DC batteries, permanent magnet DC motors, if you talk about, they have a particular withstanding capacity. The power cannot go beyond a limit to get the, say, if I talk about a four-wheeler, it is 20 to 25 kilowatt motor would be installed in that. So to have that power, either the motor size will increase, and motor size will increase. And if you talk about the DC, if you talk about permanent magnets, you would you can't accommodate that kind of power into that through the permanent magnet. So normally they use an induction motor. So induction motor, everyone knows that they uses this electromagnets. There are no permanent magnets, that there are windings which converts into electromagnet, and through which the rotor runs and then they supplies power. So it is easy to easy to get higher power like with a smaller motor also. So they in four-wheelers we are using normally inverter which converts the DC power from the battery to AC, which is supplied to the motor for its performance. And at the same time, the inverter could be used, the combination of an inverter and frequency VFD, variable frequency drive, or a vehicle control unit could be installed. And with both combination of both, the speed of the motor speed could be adjusted by either by varying the frequency or by varying the current. So motor, it provides power to rotate the wheels. It can be DC, AC type. However, AC motors are more common. So motor provides power to rotate the wheels. We everyone know that the motor provides power to rotate the wheels. So first picture that you are able to see here, this is what we call is a hub motor. Normally this is used in two-wheelers. So what would happen is this would also act as a rim of the tire. So the tire could be put over this rim. So it would act as a rim. It could directly be put into the hub, and we call it a hub motor. So there is system involved. It is like directly when you give an acceleration, it will directly start rotating. It will directly transfer the torque. Second, you can see it is like we could call it as a mid-drive. Mid-drive. It is not hub. It will rotate the tire, or it will rotate the wheel through a transmission system. Either a belt would be would be used, or a chain would be used to drive the tire. Battery chargers. So it converts the AC power available on our electric network to DC power stored in a battery. It converts the voltage level of the battery cell by adjusting the rate of charge. It also monitors the cell temperatures and control the charge to help keep the battery healthy. So battery chargers. So when the battery would get drained, so we have to recharge it. So there we would be using charger. So chargers, if you talk about typically for lead acid battery, the charges are different, and for normally lithium ion batteries, the charges are different. At the same time, if the chemistry of the battery, say if you talk about lithium ion batteries, they are available in variable different chemistry. So depending upon the chemistry also, the charger would be different. So charger itself is has a programming chip. It has a microcontroller in it. So it would be like to take a decision point whether to what extent it has to charge and when it has to get disconnected. So typically, if you talk about an EV, if you connect the charger with the EV, say overnight also, there won't be any there would be very less chances that it could cause fire or anything, because when the cutoff voltage of the battery would be reached, the charger would get automatically, it would get disconnected and it would stop enforcing or charging the battery. So this way the chargers are again smart. They are they come with a set of programs, and the charges would differ depending upon the chemistry and the type of the batteries. So thank you everyone. So this was an overview of the electrical vehicles. Whatever we have discussed, every part that we have discussed, we would be like along the course, we would be discussing everything into detail. Every component we will be discussing in detail. This was an effort to give you an overview, like why we require EVs, and if there are general doubts in the mind of a consumer or a normal person, that we try to remove, or if anyone want to ask any query, he can again put an query also. And we have tried to take a general overview of like what EV contains, what are the different components. These we would go for detailing as the course progresses. So now we can go into the Q&A session. Rohiji, if we, like, should we go into the Q&A session, because I am done with the presentation.
Govind, actually on Saturdays, what you thought, we'll take a Q&A session together, because now I think it's just 10 minutes left, and for 10 minutes I don't think Q&A it'll be sufficient. So once the second session is also over, we'll take a Q&A session together.
Consolidated we will take.
Yeah. Yeah.
Okay. So no issues like.
Yeah, I think that will be the correct part.
Yeah. Yes.
Then
So
I think if we're done
I
with
rushed
the
few. I rushed few slides thinking that like we have to leave some time for Q&A session. So.
Oh, okay. But now if you want to continue with some content, then we can, or else we'll break now and we'll meet again at 6:15.
Yeah. I think like I have.
Meanwhile, what I suggest, Rohit, if any participant have any question, write down in a chat box. Meanwhile, is it okay?
Sure. I mean, this chat box will get deleted once the call ends. So
Okay. Yes. Yeah. Okay.
No issues like I the presentation is over. We have covered all the topic. So definitely like we can take a consolidated after the second session is over, we can take a
Yes,
Q&A.
that will be fine. Yeah.
Yeah.
Sure. And just wanted to inform students also. So guys, now whenever we are having a Q&A session and whenever there are any doubts, everybody please raise their hands, and whosever hand is raised, we'll give them an option to unmute. You can ask your question and we can discuss on that question, and then we'll move to the next student. That will be easy for us to coordinate, because you guys typing in chat box and we are asking you to unmute. It is becoming a bit difficult. Just raise your hand, we'll unmute you and ask you a question. That will be much more easier. I think that's the best way to do. Mr.
Yeah,
Nabanshu,
yeah.
any inputs
No,
on
that's a
this?
perfect. That's perfect.
Okay, sure.
Okay.
Then we'll break now. I think there is some question that has come up. Why are not charged cars at home? I think we'll note down this question and we'll take it in the next Q&A. Or Govindji, would you want to address this now?
No, better the.
I'll just answer it. I'll answer this question since he has asked. So I'll answer in 2 minutes. I'll answer it.
Sure.
So I think
Wait, Govindji.
Ramesh has asked that why not
Govindji,
cars. Yeah.
Just a minute. Okay, guys, you just park your question with you. We address this question, and once we do the Q&A session after the second module, you can ask that questions. Yeah, Govindji, please.
So should I leave this or like should I?
No. You please answer this. Then.
Okay, so like Ramesh has asked why not why our cars are not charged at home. So Ramesh, to answer it, like cars are typically, they have huge batteries of 25 kilowatt or 30 kilowatt. Okay, and when that huge batteries are to be charged, we have to do it at a very high voltage and high current level. So that those are not available in your house. If you talk about domestic supply, it is available at 2.5 kilowatt hour or something. Or if you take three phase, then it is 7 kilowatt to 8 kilowatt is connected load. So that wouldn't be suffice to charge this. So it could hamper your like entire like wiring and wires and everything. So we need to have a dedicated and properly installed supply for charging the four-wheeler. You can do it at home, but you have to have a proper cable installed, proper plugs installed, or proper breakers installed before you plug in your car to your supply. So I hope I have clarified. Okay, Rohiji, then like we break for this 15 minutes.
Yeah, we break now.
Yeah. So like this, you would be sharing a new link, or we would be like.
Well, yeah, I'll be sharing a new link with you. And students, you can join the session through your login credentials itself as you're joining all the sessions. And yeah, we can break now and see you all at 6:15 sharp.
Thank you.
Thank you.
Sure. Thank you so much. Thank you all.